In this video, I'm going to build off of a previous example where we looked at a student. Her name was Sonia, and she had a student loan amount of $8,700 with an interest rate of 7.7%. And in the previous example, we assumed that the interest was capitalized. And what that means is that this student did not want to make interest payments while she was in school. She wanted to be able to go to school and not pay anything on her loan, including the interest, and then have a 6-month deferment period after graduation, which is just like a break. It puts the loan off a little bit further, and then make payments after that. And so we figured out that by doing that, we figured out the monthly payment, and we figured out a total overall cost of the loan of $16,288.80, which is pretty striking considering that she only borrowed $8,700. So she borrowed $8,700, but then ended up paying back $16,288.80. And so what I want to do here is look at the exact same student with all of the exact same amounts, and assume that the interest is not capitalized. So let's say the student decided to not capitalize the loan, which means she wants to pay interest payments while she's in school. And we're going to compare the overall cost of this option versus the overall cost if she did capitalize. So the first thing we're going to do, find the monthly interest payment while the student is in school. And so that actually we did in the last example. So you can see up here I have it written out. So we used the daily interest formula, and we got $1.83. This is per day. That's the amount of interest that accrues per day. And then times 30-day month gives us $54.90 a month. So the monthly interest rate, or monthly interest payment rather, is $54.90 a month. So this student would be paying this every single month while she's in school. She'd be paying this amount. And so then for B, it says find the payment on the loan when the full payments begin. Well, when she graduates, and after this deferment period, she actually hasn't accumulated interest like she did in the previous example because she's been paying on it. And so the nice thing now is, because interest is not capitalized, P, our principal, is just going to be $8,700. So we're going to use our monthly payment formula just like we did in the last example. So R equals P times our rate over N divided by 1 minus 1 plus our rate over 12 to the negative 12 times T power. And so I'm going to go ahead and plug all my values in. So we've got 8,700 times 0.077 divided by 12, 1 minus 1 plus 0.077 over 12 to the negative 12 times 10 power. And so from here you can do it a couple different ways. If you have a calculator like the one that I have here, a TI 3430, you can put it all in at once. I'll show you that at the end. So I'm going to do it the long way here, and this will work for any calculator, and you can skip through this if you want to get to the fast part. So what I'm going to do is I'm going to first do the numerator. So I'm going to do 8,700 times 0.077, and I didn't include that first zero, but it doesn't matter, you could have. It's the same number either way, divided by 12. And so it looks similar to how I have it written here. It's just these are not on top of each other vertically, but this divided sign means the same thing as this fraction. So they're being divided here. And with some calculators, you might even have a forward slash there, and it all means the same thing. So for our numerator, I'm going to write down $55, or 55.825. Okay, and then for my denominator, I'm going to start with just the inside of the parentheses. So I'm going to do 1 plus, and I'm going to use a parenthesis here, 0.0 divided by 12. So here we are with the fraction again. I use a division sign when I have a fraction. Enter. And so I'm going to write that down below, 1.006416 667. You can sometimes get away with rounding a little bit, but I tend to just write everything down because I'd rather just round at the end. My answer is going to be more exact that way. And so then what I'm going to do is I'm going to take that number and I'm going to raise it to the negative 12 times 10 power. So I'm going to use the exponent key and I'm going to put negative, and notice here I'm using the negative sign and not the subtraction sign, so they're not the same. So negative 12 times 10, and then, so I'm going to get 1 minus 0.464153,436. And so then my next step is going to be to do 1 minus that answer. Now you can type that all out if you want, or just do 1 minus, and a lot of calculators will have this answer function. And so in this case, I'm going to hit second and then that negative sign so that I can get that answer ANS to come up. And what this means is it's just going to do 1 minus that previous answer, the number on the previous line. And it saves me from typing it all in. But again, you can totally type it in and you'll get the same answer that way. So I'm just going to come down here and I'm going to write my numerator down again. And then I'm going to write down my denominator. So 0.535,846,564. And then last step, I'm going to just divide these two. So I'm going to type 55 point, oops, too many 55s there. Okay, so 55.825. And then divide it by, and I can use that answer key again, answer function, to just plug in this previous line's answer. So second, to get that answer to pop up, so, or you can type it in by hand, and then you should get 104.1809423. And then since we're looking for a monthly payment, we always want to cut it off after 2 decimal places, or the hundredths place. And so since there's a 0 after that 8, it means this is all going to go away and that 8 just stays an 8. So my monthly payment is $104.18 per month. Now, if you watched the previous video with the last example, just for comparison, that monthly payment was $135, I believe. Yes, $135.74. So she's saving money here. Her monthly payment over 10 years is lower than what it would have been had she not paid interest while she was in school. So it might seem like it's not a good deal to be paying while you're in school, but the nice thing is then the monthly payment after graduation is lower. And so, you know, it's offset there. So let me show you real quick how you could do that in one, with one function basically in the calculator. So you can hit the N over D button, and then I'm going to just plug in 8,700 and times, and then hit the fraction button again, and I'm going to put 0.077, arrow down, 12, arrow over to get out of that fraction, and then parenthesis. And then we're going to come down to the denominator, and I'm going to type in 1 minus. I'm just copying exactly what I see on my paper there. 1 plus, and then the fraction key, 0.077, down arrow, 12, and then the right arrow to get out of that fraction. You want to make sure you always get out of the fraction before doing that parenthesis and raising it with that exponent. So I'm going to hit the exponent key and then negative 12 times 10, and then I'm going to hit enter, and then I get the same answer. So definitely faster, but it's nice to have both options depending on what calculator you have. So that was part B. So now we're going to move on to part C. And so C wants us to find, it says how much less would Sonia pay in total if she did not capitalize the interest. So I'm just going to figure out her total when not capitalizing. And capitalize. There we go. And again, that's when she's making payments while she's in school. So the first thing we need to do is calculate those interest payments. So her interest payment, she's paying $54.90 a month, and you have to figure out how many months she's going to be making those payments, which is the time she's in school plus any deferment period. Now it said that she was in school for 3 years and 6 months, and that the loan was also deferred for another 6 months after graduation, so an additional 6 months after that. And so in the last example, we calculated, so 3 years would be 3 times 12 if I want to know the total months in that, plus another 6 months, plus that other 6 months. And if we add that all together, we end up getting 48 months. That's called the accrual period in situations where the interest is capitalized. So I'm just going to take $54.90, which is her monthly interest payment, times 48 months, because those are the months where she's making those interest payments, and I'm going to multiply that together to get a total that she pays in the interest before the regular payments begin. So when you multiply that, you get $2,635.20. So this is interest, okay, before payments. Okay, then the next thing I'm going to want to do is I'm going to find the total from her regular payments. So we figured out in the last step that she's going to pay $104.18 a month. This is her monthly payment after graduation. She's going to do that 12 months a year for 10 years. So a long time. And that amounts to $12,501.60. Now that's not her grand total because she made those interest payments while she's in school. So if we want to know the grand total here, we're going to have to add those two together. So I'm just going to do another bullet. So the grand total for this loan, and by not capitalizing interest, is going to be the $2,635.20 plus $12,501.60, and I'm going to get $15,136.80. So this is the total when she did not capitalize. Okay, and so we want to compare that to the total when she did capitalize. So we figured out from the last example that when she capitalized that interest, she wasn't making those interest payments while in school. Her total for the loan was $16,228.80. I'm going to subtract $15,136.80. That's her grand total when she did not capitalize, to see the difference. And if I do that, I get $1,092. And so that is the answer to this last part C. So basically, by not capitalizing the interest, which means she's making payments while she's in school, she saves $1,092 over the life of the loan.